Welcome to the lecture devoted to missing replacement. Part of the material presented in this lecture is taken from the following book, while transcription and interpretation errors are responsibility of the lecturer. In this lecture, the following concepts will be introduced. We start with the concept of missing data, and then we focus our attention to different strategies for missing replacement, including record removal, manual imputation, global constant, mean and mode replacement, conditional mean replacement, and finally most probable replacement. By inspecting the customer calls database, you already raised the issue of the question mark. However, your friend, the CEO of the telecom company, already explained to you that question mark is used to represent a value of some attribute which has not been recorded into the customer calls database. In particular, for the portion of the customer calls database we are analyzing here, we have that the first record with reference to the attribute churn has a question mark, the fourth record with respect to the state attribute has a question mark, and the sixth record with respect to the attribute international call as a question mark. You know now that all these question marks values are called the missing values or missing data or again missing observations in the terminology of data mining. You know that multiple causes are responsible for missing data or missing observations. We present here just a few. For example, it may be the case that the attribute's value is not always measurable or observable. It may be also the case that the attribute was not considered to be relevant when first collecting the data. Furthermore, it may happen that a misunderstanding concerning the guideline to save the data occurred, or a bad functioning of measuring and/or of saving devices. Or finally, an inconsistent set of values are obtained with respect to other attributes. The missing data or missing observation problem must be addressed, if any, before starting any data mining study. But at this stage we are left with the following question. Which are the options to solve the missing data or missing observations problem? Let us now introduce the main options to solve the missing data or missing observations problem. To this extent, we exploit this portion of the customer calls database where yellow is used to emphasize where the missing values are located. The first option to solve the missing data or missing observations problems that we present is the record removal technique. In this case, we simply remove each record containing at least one missing value. So, in this portion of the customer call database, we will remove the first, we will remove the fourth, and we will remove the sixth record of the portion of the data. But let's see which are the drawbacks of the record removal strategy. Assume to this extent that 1% of the data is missing for each field, which is a very small percentage. And furthermore, assume that the missing pattern is at random, so there is no hidden relationships linking the way by which missing values for different attributes are dependent. If you assume that your dataset consists of 9 attributes, then the probability of no missing data for a given record will be equal to 0.99, so 1 minus 0.01 powered to the 9th, which is equal to 0.9135. This simply means that you have a probability of 9% that the record will be deleted, will be removed, and this simply represents that around 9% of the observation of the records of the available dataset will be removed due to missing data. But what happens if the number of attributes is increased to 100, which is still a very small number when we have to analyze through data mining a given problem? So in this case the probability rises to 0.99 powered to the 100, which is equal to 0.366. This simply means that around 2/3 of the available data of the dataset will be removed, will be not used if you use the record removal strategies. And it is quite clear then a lot of valuable information will be discarded and will be not used for the data mining study. A second option is offered by the manual imputation strategy. This missing replacement option requires that you manually fill all the missing values. This is therefore an extremely time-consuming strategy. The third option is known under the name of global constant replacement. In this case, you replace with a constant value all the missing observations of the dataset. For example, you can replace with 999 all the missing observations that you have in your dataset. The fourth option to solve the missing data or missing observations problem depends on the type of the attribute that we are taking into account. In particular, if the attribute is discrete, either nominal or ordinal, then the option will consist of mode replacement. To show how mode replacement works, we make the assumption that this portion of the customer calls database represents the entire dataset that we have to analyze. We also focus our attention to the attribute state, which is a discrete one, and in particular it is a nominal attribute. We can see that the fourth record of this dataset is characterized by a missing value for the attribute state. So we proceed as follows. We compute for each of the possible values that the attribute state can take, which is the count, so which is the frequency of that value. In particular, we will have that KS occurs 3 times in the 9 records without the missing value, while OH, OK and NJ occurred just once. Then we simply replace the missing value of the fourth record of this dataset with the value of the state attribute, which is the most represented into the available dataset. So with the value KS, that in our case is the most frequent. So it represents the mode of the empirical distribution of the attribute state. However, in the case where the considered attribute is not a discrete one but a continuous one, we apply the mean replacement in place of the mode replacement. To show how it works, we focus our attention to the attribute int calls, and we can see that the sixth record is associated with a missing value. So to replace this missing value using the mean replacement, we simply compute the mean of the int calls attribute using all the valid observations that are available in the dataset. In this case, we have that the mean is equal to 4.77. Therefore, the missing value associated with the sixth record for the international calls attribute will be replaced with the mean, so with 4.77. When the attribute whose missing value have to be replaced is suspected to depend from other attributes of the available dataset, a clever strategy, a clever options than mean replacement and mode replacement can be used. These options goes under the name of conditional mean replacement. To show how conditional mean replacement works, we focus again our attention on the Intel calls attribute, whose sixth row, sixth record is associated with a missing value. We also make the assumption that the Intel calls attribute has some dependence from the state attribute. This can be due to some a priori knowledge from the expert. Then we proceed as follows. For the records characterized by the missing value of the considered attribute Intel calls, we check which is the value associated with the state attribute. In our case, this value is ks. Then we find all the records where the attribute state takes exactly the same value ks, and in our case we have that the first and the ninth record are such. Then we proceed as follows. We use just those records where the attribute state takes the value ks. In our case, these are the first record and the ninth record. And we simply use the values associated with the attribute Intel calls to compute a mean that in our case will be called the conditional mean, because it is the mean conditional on the value ks for the attribute state. In this case, the conditional mean is equal to 3.5, and so it is used to replace the missing value associated with the sixth record and in particular for the attribute Intel calls. A similar argument can be developed in the case where the considered attribute is a discrete one. But in this case we will talk about conditional mode replacement in place of conditional mean replacement. The last option we present goes under the name of most probable replacement. To show how it works, we focus again the attention to the international calls attribute. To develop the most probable replacement option, we also make the assumption that the int calls attribute depends on the day means attribute. To implement the most probable replacement option, we proceed as follows. We first remove the records where the international calls attribute is missing, so we remove the sixth row of the available dataset. Then we remove all the attributes of the dataset except from day means and international calls. Then we fit a linear regression model where the attribute Intel calls, so the attribute characterized by the missing value, is the dependent variable, while day means is the independent variable. Alpha 0 and alpha 1 are the parameters to be estimated of the linear regression model, while epsilon is the error term that is not further described here. Using the available data of day means and international calls and fitting the model, the linear regression model, we get the estimates of alpha 0 and alpha 1 to be equal to 2.23 and to 0.012. Then this linear regression model can be used to make a prediction about the value of the attribute international calls for the record associated with the missing value. To this extent, we use the value associated with the day means attribute for the records where international calls is missing and fill it into the linear regression model. So day means is set to 223, 4. So 223, 4. The linear regression model provides the following forecast, the following prediction for 91 for the missing value of international calls. Therefore, this value is used to replace the missing value for the attribute international calls. To conclude on the most probable replacement option, we can add something more. For example, it is often the case that more than one attribute can be used with the linear regression model. In this case, we develop a multivariate linear regression model. Furthermore, we also have to say that more complex models can be used, so we are not constrained anymore to use linear regression models. Finally, it is possible to manage the case of qualitative attributes also, but in this case, appropriate models have to be used.